This video is going to take a look at diffusion and osmosis. The first thing that you have to look at in order to understand diffusion and osmosis is that molecules are always moving. They never stop. And they're always moving randomly. And they bump into other objects, and as they bump into other objects, they change direction. So they're moving left and right and up and down and around, and that is what allows diffusion and osmosis to occur. So diffusion is the movement of molecules from an area of high concentration to an area of lower concentration. So in this diagram, we have lots of blue dots, or a high concentration of blue dots over here. They will diffuse to this area which has low concentration over here due to that random movement of molecules. So in this case, moving from high to low concentration. This will continue until equilibrium is reached, or until both areas have an equal concentration or amount of the molecule in it. So for this example, the red molecules have a high concentration on the left, and the blue are evenly spaced. The red will diffuse across until there's equal red molecules throughout the entire solution. So in this case, we have two cells. The molecules are diffusing from the cell with high concentration to the cell with a low concentration. What types of things diffuse in and out of cells? Well, there's oxygen, there's water, sugars, carbon dioxide, waste products. Basically anything that has to come into or out of a cell gets into or out of the cell by diffusion. It is a fairly slow process, but it is very effective. So what factors can affect the speed at which diffusion happens? So what will make these molecules diffuse really quickly? Or what will make them diffuse really slowly? Well, temperature can make it go faster or slower. The particle theory of matter says that when particles get heated up, they get more energy and they move around more. And the more a particle is going to move, the more things it's going to bounce off of. The more things it's going to bounce off of, the more it's going to spread out or diffuse. So therefore, the higher the temperature, the faster diffusion is going to happen. So this is what you want to write in your note template, that higher temperatures will cause diffusion to happen faster. But that means that the opposite is true. If we made the temperature colder, the particles are going to move slower. Therefore, diffusion will happen slower as well. Surface area will also affect how fast diffusion happens. Now, surface area means the area of the cell or a material that is exposed to the environment around it. The larger the surface area, or the more surface there is exposed to the environment, the faster diffusion will happen. And that's because if there is more surface in contact, that means that there is more area where collisions can happen. And if there's more area for collisions, it means that those molecules can spread out faster, and spreading out is diffusion. Concentration gradient. Now, concentration gradient just means difference in concentration. So if we look down at this example here, there's a high concentration and a low, none over here. So this is a very large gradient or difference in concentration. Lots versus none. Okay, so the bigger that concentration difference is, the faster diffusion is going to happen. So if you took a glass of water and you put in a spoonful of sugar, right? You have a lot of sugar in that spoonful, that's a high concentration, and there's none in that glass to start. So that diffusion is going to happen really quickly. Whereas if you already had some sugar in that cup and then you added more sugar, the diffusion gradient is not as large, so it won't happen as quickly. Size of particles. The smaller the particles, the faster they're going to diffuse. Why? Smaller particles can kind of zip in between other things, and they can kind of mingle their way through things, which allows them to spread out faster. And spreading out faster is diffusion. Now, osmosis is a special type of diffusion. It's the diffusion of water across a semi-permeable membrane. Semi meaning partially, permeable meaning allowing things to get through. So a semi-permeable membrane is like this red dotted line. It will allow some things through, but not others. So if you look at these molecules, they're going to be too big to fit through. So In terms of osmosis, water does the moving to reach equilibrium or equal out the concentrations. So let's look at this beaker here. We have a semi-permeable membrane that doesn't allow these purple molecules to move back and forth. So we can see the concentration gradient. There's a lot of them on the right, not so many on the left. Ideally, they would like to diffuse to the left, but this membrane is preventing that. So the only way to get equal concentrations then is take some water from here and move it to this side and kind of water down the molecules on this side. And that's what happens in osmosis, is the water does the moving to create sides with equal concentration. So some examples of where we might see this in real life is with blood cells. So if you took a red blood cell and you put it in pure water, there are a lot of molecules inside the red blood cell, and the cell membrane around the outside is a semi-permeable membrane, meaning that it keeps those molecules inside and won't let them move out to reach equilibrium. So the only way to lessen the concentration on the inside is by adding water or diluting the inside of the cell. And when that happens, the cell takes in more water and it swells up. In terms of actual red blood cells, they can swell so much that they burst. And this is when somebody at the hospital has to be really careful putting an IV or fluids into your veins to make sure that it's the right concentration, because you don't want your red blood cells to burst. In the opposite, if you take a red blood cell and put it into a liquid that has a lot of solute in it, okay, there's less solute or a lower concentration inside the cell. So what's going to try to happen is the water is going to leave the cell and try to water down this outside area to reach equal concentration. The cell will then shrivel up. And if the cell is all shriveled up, it can't do its job properly either. Whereas if a cell is put into a solution where there's equal concentration on the outside as naturally occurs on the inside of the cell, water is still going to move in and out, but it's going to move equally. Every piece that moves out, there's going to be some that moves in, so the red blood cell can maintain its ideal shape and work properly. So let's compare and contrast osmosis and diffusion. Osmosis, what is unique to osmosis? It has to be through a semi-permeable membrane, and it's only the movement of water, nothing else. Only water is doing the moving in osmosis. Whereas when we look at diffusion, it can be spread out over a large area, and it's the movement of everything, all different types of molecules except water. So it can be the movement of carbon dioxide, sugars, oxygen, food coloring, but not water. What do they have in common? Both of them are the movement of molecules to create an equilibrium or equal concentrations throughout an area.